Okay, we're in examples for section 10 now. This is basically a review of what you did in Math 100. We're not going to do a tremendous number of problems here, basically just to illustrate what you've done in Math 100. So let's take a look. And certainly, I'm not going to say one method's better than the other, but you should know all the methods that were discussed in Math 100. So in Math 100, the first method was a technique, whoops, sorry about that. It was a technique called solving by graphing, right? So we have a linear system. And that linear system, I'll write it down for you, is two equations, and they're linear equations, they're lines. So that's x plus y equals minus 3. And the other equation is x minus y equals 5. The difficulty with this for students is they try to do it way too quickly. And what I'm going to claim over here is I would just do one line at a time. So we're going to graph this technique of graphing. So what I would do here is just pick 2 points that I find easy to deal with. And what point's easy? I'm going to say if you set x to be 0, you would get minus 3 for the y. All right, fairly simple. Now, if you set y to be 0, what would you get for x? You would get minus 3. And then what we recommend you do is you plot those 2 points. I'm going to do that over here. And I'll plot those 2 points. All right, so what I plot? I plot the point 0, minus 3, and I plot the point minus 3, 0. Then what we recommend you do is draw a line through those 2 points. It's a line. All right, let's go to the next one. And the next one I'll do in blue. Again, it's technique of graphing. Well, if I chose x to be 0, what would you get for y? You would get minus 5. Fairly simple. It's a very simple equation. If you set y to be 0, you would get x is 5. I'm going to plot those 2 points, and those 2 points are 5, 0. And the other point is going to be minus 5, 0 minus 5. And then you would draw a line through that. Now, granted, a lot of students, and myself included, really are not, great artists when it comes to drawing things. So what happens is it might be really tough to find out what's called a point of intersection. But I'm seeing something over here that looks like it might be the point of intersection. So what am I looking at? I'm looking at the x-coordinate. And, I really don't know if that's 1 or not. I'm going to make a stab at it and say it probably is 1. And what's over here? It's probably minus 4. But I can't guarantee that. I cannot guarantee that x is 1 and y is minus 4. What I need to do is I need to check it. And where do you check it? You always check back in the original system. This is the original system. I want to check it. And I'm going to check it right over here. I'm going to see if this makes any sense at all. So if x is 1, the first equation would become 1 minus 4. And that, in fact, does equal minus 3. That's good, but it must work in both cases. What's the second one going to be? 1 minus a minus 4, which is plus 4. And that also is correct. So I know this is the point of intersection. All right, let's go to the next one. Next one's also a linear system, but they want me to do it by substitution, which is another technique that you did in Math 100. Now, I like this technique better than I like graphing because graphing to me is time consuming and the accuracy of it really comes into question. All right, did I get the right one? I don't know. Let's say substitution. And what does that mean? In substitution, what we're going to do is we're going to look at these equations over here and we're going to try to solve one of them for either x or y. Well, this one over here, the second equation is already solved for y. What are we going to do over here? We're going to take this y, which is also this thing over here, and going to plug it into the other equation. Now, granted, if you plugged in y again, that wouldn't be good. So what I'm going to plug in instead, I'm going to plug in the other form of y, which is x plus 1. So what I do, I substitute it. All right, what did I substitute? Well, from the second equation, I said y was x plus 1. I just substitute that into the first equation. And again, I believe y is x plus 1. At least that's what I'm being told. What do you get over here? You get 2x minus 4x minus 4, just using very simple distributive product multiplication. Let's keep going. What do you get over here? Well, 2x minus 2x is minus 2x minus 4 equals 0. I'm going to keep solving it by adding 4 to both sides. Now I'm going to divide both sides by minus 2, and you get x is minus 2. And here comes the problem. You got x. What's y? Well, again, I want to tell you, y is x plus 1. So y is, well, what do I believe x is? I believe it's minus 2, and that's plus 1. So I believe y is going to be minus 1. So I believe I have a point of intersection. That point is going to be minus 2 for the x, minus 1 for the y. I still want to check it. And what do you check it in the original system? So what do I have? Well, 2 times x, that's my first equation. That would be minus 4, right? Now, if y is minus 1, I get plus 4. And that certainly does equal 0. Worked out beautifully. Let's look at the second equation. What does it say y is? Well, I believe it's minus 1, and I believe x is minus 2. Is this satisfied? Of course it is. This is the correct answer. All right, let's go to the next page. And give me 1 second to do so. And you know what? I don't think I insert the next page. So I got to do that now. Yeah, I just put 1 page down. So let me insert. And that's what, page 222, right? So let me insert page 223 then. Long document, right? Let's see. Well, I just did 222, so I'll do these 2 pages here. I'll insert them. We'll take a look. All right, go to the next page. And, I want to point out they still graphed it, but you don't have to graph these if you don't want. All right, let's take a look at number 3. And number 3 says solve by using the addition method. Now, I'm a fan of the addition method. I actually prefer it. And the reason for that is it doesn't matter me drawing something or me solving an equation for a given letter. So let me write down what I mean by the addition method. It's also called elimination or Gaussian elimination. So I'm going to write it down, and I'll talk about the way I would describe it in Math 100. And again, it's another technique that your teachers illustrated in Math 100. Well, what you're going to do over here is you need to pick either an X or a Y to eliminate. And that's up to you. I mean, you might say, well, I want to eliminate the X first. It's up to you. Or eliminate the Y first. It's up to you. I'm going to eliminate the Y. You put a little arrow above it. And what I want to do through an addition, I want this to disappear. Unfortunately, if I add this together, what would I get? I would get 7x plus 5y. Well, that didn't disappear. So I'm going to erase that. That was no good. So what I got to do is start. How would it eliminate? They can only eliminate if they're opposites, and they're not opposites. One is 3, the other one's 2. So what I do is I find the LCM. I'll write this down. The LCM between 3 and 2. Whoops. And that's pretty simple. That's just 6. So what do? I want to make one 6, the other one to be minus 6. So I'm going to multiply the top by 2 and the bottom equation by minus 3. Right now, if I did that, let me do that over here. What are you going to get? 4x plus 6y. I want to repeat what I'm doing. I'm multiplying the top equation, which means both sides, by 2. So 2 times 2x is 4x, 2 times 3y is 6y. Well, 2 times 4 is 8. And I'm going to multiply the bottom equation by minus 3. What does that mean? I'm multiplying both sides by minus 3. What do you get? Minus 15x minus 6y equals 3. Now what am I going to do? Well, I'm back at the same thing. I'm going to add these things together. If you did that, I'll put a little line here just to remind you. It kind of reminds me of addition. What do you get? Well, minus 15x plus 4x is minus 11x. 6y minus 6y is nothing. That's why it's called elimination. And 8 plus 3 is 11. Now, what do you get over there? You get x equals minus 1. Fairly simple. Now, by the way, someone says, could I do that again? Of course you can. Do people do it again? Sometimes they do, sometimes they don't. What I'm going to do is I'm going to erase this over here. And instead of eliminating the y's, what I'm going to do is eliminate the x's. So what am I looking for? I'm looking for the LCM between 2 and 5 now. Fairly simple. It's just 10. So what am I going to do over here? Well, I'm going to multiply the top equation by 5 because I want to make it that x a 10. But I multiply the bottom equation by minus 2 because I want to make it the opposite of 10. And what would you get over there? It's fairly simple. And what do you get? Let's write this down. I'll multiply the top equation by 5, or both sides by 5. I would get 10x plus 15y equals 20. What do you get in the second equation? Minus 10x. Again, I'm multiplying the second equation by minus 2 or both sides. Add them together. What disappears now? Well, I'm looking at it, the y. I mean, the x disappears. That's what he left off with. Well, 10x minus 10x is no x's. 15 minus 4 is 11. And 20 plus 2 is 22. Divide both sides by 11, and you get y is 2. So now I have my answer. What's my answer? X is minus 1, and y is 2. Now again, do I make mistakes? All the time. I want to emphasize, you need to check it. Where do you check it? In the original. Let's check it. All right, what am I checking? I'm checking what I believe is an answer, which is minus 1 comma 2. And again, I'm going to check it now. So let's see if the first equation makes any sense. And again, what's x? X is minus 1. So I'm going to write this down, minus 2. And the second equation, I get minus 5. And that's if x is minus 1. If y is 2, what do I get? Plus 6. That's in the first equation. In the second equation, you get plus 4. What's minus 2 plus 6 is 4. That's exactly what they said it is. All right. What's minus 5 plus 4? Minus 1. That's exactly what they said it is. So now I know that's the correct answer. All right. By checking it. All right. That's good. All right. So that's a short section. I also want to point out there's Sage code over here for those students interested in looking at the Sage code. And I would recommend you do that. There's one thing I forgot to put down over here, and I'll write that down for you. Sage. You should always start by resetting. I think I've been doing that pretty consistently. And then type those commands in. What's the first command going to be? Basically, you're just defining a variable. The first command just says, give me a clean sheet of paper. So it's really purging all the variable data. And then X and Y are variables. And then you're going to plug it in. And what do you plug in? Solving an equation. I want to point out, if you look at this thing over here, this is 2 equations, 2 unknowns. I'll write down what it looks like to me. It looks like 2x plus 3y is equal to 4. Remember, the double equal signs in Sage means an equation. The second equation is 5x plus 2y is equal to minus 1. And what is it doing? It's solving for xy. So what's going to spit back out an answer to that? The question is, have we done that one? Well, we just did it. So what's Sage going to spit back? An answer. And you're going to be shocked by this. Sage can actually spit back an answer pretty quickly. Here's the deal, though. It probably takes more time to type that in than it does to solve that equation by the technique of elimination. As things get bigger, though, you want to know how to do this by computer, because as things get bigger, they get far more difficult. Thank you.